All right, more proofs. All right, here we go. Um, so this one's kind of interesting because I'm giving you a congruent triangle and then asking you to prove triangles congruent, which is kind of hinting at where these congruent triangles are would be going had we got a level time. Um, and it's really all centered around this idea of CPC-TC. So if I know triangles are congruent and all the parts are congruent, and if all the parts are congruent, well, I can use that maybe in conjunction to prove something else. Let me kind of try to demonstrate what I mean. So if I am looking at these two triangles, I'm given that ZWV is congruent to YXV. And if in this case the diagram happens to be marked, but if it wasn't marked, you could easily mark it up all yourself. But I'm going to go ahead and code this in pink so you can maybe see what these two triangles are. So I have ZWV, so Z up to W down to V is congruent to YXV. Okay, so these two I have labeled in pink. And I need to prove, and I'm trying to mark this up, say in blue, that two bigger triangles, which actually include these, are congruent. So I have ZWY is congruent, and now let me mark this one a little bit lighter blue. Uh, Y, X, Z. Okay. So we need to take a second and take stock what we really have here and see how close we are to proving these are congruent. So please keep in mind that you have all the things in place that you normally do. You can use side, 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 angle, angle, side, and angle, side, angle to prove congruency. So if I'm looking at these two triangles, the one marked in blue and then the one marked in lighter blue, and let me actually try to remove this pink triangle. That's starting to get a little messy. Okay. So if I look at these two triangles, I can see them actually pretty close to proving them congruent. I have a lot that's marked because triangles are congruent as part of the given. Namely, I have a side here which would be corresponding congruent to one on the right. I even have an angle. If I look at this one marked as angle 2, I have that angle is congruent, so I already have an angle and a side. I just need one more piece. I just need another angle, or I need another side, and you got to be careful. The side's got to be in the right location. So here's where the temptation is going to be. Some people are going to be like, "Oh, Mr. Collins, look, this one right here is shared in both triangles. Won't that actually prove congruency?" It won't, and here's the reason why. Look what that one gives you. This one it gives you angle, side, side, and of course angle, side, side here as well. Angle, angle, side is not one of our congruency conditions. In fact, it was one of only two that didn't work because angle, side, side actually could allow for two possibilities of triangles instead of just one. So although this was a good idea, ultimately that side's not going to, oh, excuse me, ultimately that bottom side is not going to work, but I do have the capability of possibly finding an angle or possibly finding another side. So here's what I'm looking at. I'm looking at the other side and trying to hit like side angle side. Because look, I'm seeing that this guy from here to here is marked with a triple tick, and so is this one, which although I don't know the length, I know they're congruent. And then to continue on, I'm seeing a double tick here and a double tick here, which means those pieces have to be the same length too. So wait a minute, if ZV is the same as YV, and then the other pieces of them, Vx and Vy are the same, if I add those all together, you know what? Those have to be the same length. This actually gives me side angle side. Now, the last side is going to be a little bit more work, but in the end, I have enough for side angle side congruency. So let's get to it. If I'm going to prove side angle side congruency, I have the information I need. I just have to mark it up. So I'm going to do the easy piece first. So I have ZW congruent to xy. Now I have to be careful here because it's not because it's given. It's actually because of CPCTC. It's given that my triangles are congruent. Okay? Um, and I could even put that in my proof, and probably should put that in my proof. What's actually given to me is that triangle ZWV is congruent to triangle YXV, and because of that reason, because it's congruent, I can extract that ZW is congruent to XY because of CPCTC. Now that gives me a full side length. Okay? Same is going to be true for this angle. We were given that triangle ZWV is congruent to triangle YXV, and because it was given, we can conclude that angle 1 is congruent to angle 2. And again, that's going to be because of CPCTC. Congruent parts of congruent triangles are indeed congruent. This last one's going to be a little bit tougher. Um, Again, we have to start with our main given. We have ZWV is congruent to triangle YXV. So that's going to give us actually a couple things. We can conclude that, or I'm sorry, it's given. Therefore, we have that ZV is congruent to Vy, and let's see, WV is congruent to Vx. What I'm naming there are actually each of these four pieces in pairs, the side length. So ZV side length and Vx side length, or Vy, excuse me, side length are congruent, and Vx and Yv. So we have all those pieces are actually congruent. So that's going to be because, again, of CPC-TC. Well, if those pieces are all congruent, by definition, they have to be equal in measure. So ZV is equal to Vy in the same way that Yv is equal to Vx. And that's going to be because of definition of congruency. Okay, so the reason that's important is because if I want to add up to this entire side length, Zx, I'm going to have to use pieces. Namely, and I'm going to kind of just break off and do a little independent piece right here. Zx is actually the result of adding xv plus vx. Okay? In the same way, the full length of this triangle, wy, is the result of adding the two pieces together, vy plus vw. Okay? And since I'm adding just a bunch of segments together, this is actually going to be one that we haven't used too much yet, the segment addition postulate. Okay? But wait a minute. If if I have these two sentences and I combine them with these statements here, I know they're interchangeable, I can actually make these look the same. Check this out. So if I know Zx is the same as Zv plus Vx, I can also say that Wy is the same as Zv plus Vw, but I can exchange both those pieces, uh, in this case for Vx. And I can do that because of this step right here. It was Uy, but, I'm sorry, Vy, but Vy is the same as Xv, which is why I replaced it here. In the same sense, it was Vw, but Vw is the same as Vx, which is why I'm now writing it as Vx. It's just going to be a substitution problem. Now they look exactly the same. If you look, they actually equal the same exact thing. So I can then say Zx is the same as Wy. And that's going to be because of transition or substitution. Either one's really fine. So we have Zx the same as and Wy the same as. And so we can actually say they're equal to each other. And of course, if they're equal, then I can say that Wy is congruent to Zx because of the definition of congruency, which actually gives me my third side. So I had my side proved, my angle proved, and it took all that to actually prove the third side. But if I bring these three pieces together, boom, boom, and boom, I can conclude my triangles are congruent, which was what my original proof statement asked me to do. Triangle CWY congruent to triangle YXZ because of side angle side triangle congruency. Okay, and that is actually the full proof. So the first two weren't too bad. The second side kind of blew up into something a little bit more. But in the end, that's sometimes how proofs go. Like it's not always a really simple, easy path. Sometimes it takes a little bit more, a little more involved to kind of get towards the end. Right. So that is that, and I will see you in the next one.